Good afternoon. Myself Kumari Silky, Assistant Professor, IIMT College of Science and Technology, Greater Noida. Today I will give the small session on process scheduling fundamental in operating system. So at first, what is operating system? An operating system is a program that act an interface between computer user and computer hardware and control the execution of program. Now the terms comes in operating system, that is process scheduling. Process scheduling is the activity of the process manager that handle and removal of the running process from the CPU and the selection of another process on the basis of particular strategies. The process scheduling is an external part of the multi-programming operating system. Such operating system allow more than one process to be loaded into executable memory at the time of loaded process and share the CPU using the time multiplexing. Now, category of scheduling, there are two type of scheduling category. First is non-primitive and second is primitive. In non-primitive scheduling, here the resource can't be taken from a process until the process complete the executions, and the switching of the resource occur when the running process terminate and move to the waiting state. In primitive scheduling, here the operating system allocate the resource to process for a fixed amount of time, and during the resource allocation the process switch from the running state to ready state, from waiting state to ready state. This switching occur as the CPU may give priority of other process and replace the process which higher priority with the running of the process. There are the two type of scheduling. In one is primitive and second is non-primitive. Now, process scheduling queues. In process scheduling queues, the OS maintain all the process control blocks in process scheduling queue, and the OS also maintain and separate the queue for each the process state and process control block of all process in same execution state are placed in the same queue. When the state of process is changed, its process control block is unlinked from the current queue and move to the new state queue. This is process scheduling queue. Now, the operating system maintain the following important process in process scheduling queue. First is job queue. In this queue, uh, we keep all the process in the system. In ready queue, this queue, we keep all set of process residing in main memory and ready and waiting to execute. A new process is always put in queue. Now, device queue, the process which are blocked due to unavailability of input output device that are placed in the device queue. Now you see in pictures, that is job queue, and if come into ready queue, and ready queue, then the CPU is allocated. If not resources available, then we come into waiting input output queue. Then again go to the input output, and again go to the input output, and then go to the ready queue. Then if the termination is occurred, if the then it is terminated. If the waiting new other process is executed, then it goes into input output waiting queue. The OS can use different policy to manage each queue, that is first in first out, round robin, priority basis. This is the algorithm that are used by operating system to manage the jobs to maintain the queue process. The OS scheduler determine how to move the process between ready and running queue, which can be only have the one entry per processor. on the system. In the above diagram, it has been seen the merge into the CPU. Now, two-state process model. That the two-state process model refer to two process, that is running or not running state, which are described below. In running, when the new process is created, it entered into the system as goes into running state and process is executed. That is simple, it is a running state. If now comes on the not running state. In not running state, the process that are not running are kept in queue, waiting for their turn to execute. Each entry in the queue is a pointer to a particular process. Queue is implemented by using linked list. Use of dispatcher is allowed. When a process is interrupted, that process is transferred into the waiting queue. If the process has completed or terminated, then the process is discharged. In either cases, the dispatcher then select a process from queue to execute. Now, scheduler. The scheduler are a special type of system software which handle the process scheduling in various ways. Their main task is to be select the job to be submitted into system and to decide which process to be run. Scheduler are three types: long-term scheduler, short-term scheduler, and medium-term scheduler. At first, we discuss long-term scheduler. In long-term scheduler, it is also called a job scheduler. A long-term scheduler determines which process are admitted to the system for processing. It selects process from the queue and loaded them into memory for execution. Process load into the memory for CPU scheduling. The primitive objective of the job scheduler is to provide a balanced mix for job such as input output bound and processor bound. It also controls the degree of multi-programming. If the degree of multi-programming is stable, then the average rate of the process create must be equal to the average departure rate of the process leaving from the system. Once the system, the long-term scheduler may not be available for minimal. The time-sharing operating system have no long-term scheduler. When the process changes the state from new to ready, then there is use of long-term scheduler. Then short-term scheduler. It is also called as CPU scheduler. The main objective is to increase system performance in accordance with the choose set of certain criteria. It is the chance for ready state to running state for the process. CPU scheduler select a process among the processes that are ready to execute and allocate CPU to one of them. Short-term scheduler are also known as dispatcher and make the decision for which process to be executed next. Short-term schedulers are faster than the long-term scheduler. And third one is medium-term scheduler. The medium-term scheduling is a part of swapping. It remove the process from the memory. It reduce the degree of multi-programming. The medium-term scheduler in charge of handling swap out process. The process, the running process may become suspended if it make an input output request. A suspended process cannot make any progress toward the completion. It is in the condition to remove the process from the memory and make space from the other process. The suspended process is moved to the secondary storage. This process is known as swapping, and swapping and then the process is said to be swapped out or rolled out. Swapping may be increased to improve the process mix. Now, the terms, very important terms comes, that is context switching. A context switching is the mechanism to store and restore the state or content of CPU is in process control block so that a process execution can be resumed from same point at a later time. Using this technique, a context switcher enable multiple processes to share a single CPU. Context switching is an essential part of a multitasking operating system features. This is the diagram. Here is the process 1, process 2, process 3, process 1, process 2, process 2, process 1. And the time slot will be given. That is non-repetitive type of scheduling where process 1 is executed and save the process 1 state. If process 2 released to the process 2 and the process 2 is restored and start running, then the time is over, then control to the process 2. So that's why the time scheduling in the basically terms of scheduling is referred to the, there the multiple process are in queue, and we allocate the time resource to be given. There the we decide the 2 seconds given to the each process. If the process is completed in 8 minute 8 second, then the 2 minute 4 times will be, one process will be executed 4 times. That's why the many processes are in queue. We divide the time slot to them and to for the execution, that will be help to increase the scheduling process. If the process has higher priority, then the other process should wait there, and that process should go for the execution. That is, in that way they have process scheduling, and basically major terms comes in the operating system, that is scheduling, how process should be execute. Context switch are computationally incentive since register and memory state must be saved and restored. To avoid the amount of context switching time, some hardware system employ two or more set of processor register. When the process is switched from in one process to another, then the way following steps should be used. First is program counter. We all have knows what is program counter. The main function of program counter to uh, re, um, to save the instruction of the next execution and work on the current program should be executed, and the also work of program counter to calculate and to monitor what program should be executed and what program should be executed for next. Scheduling information. Scheduling information also an important term, that is the which algorithm is used for the scheduling. We using first in first out process, round robin process, which algorithm should be used. Base and limit register value. We all have knows what is the use of register. The register is store the current running current running process for say currently use register, change state, input output state information, or accounting information. These are the all working of or main keep the records of all these things are in terms comes into context switching. Thank you, and